Now, retinoblastoma, let me show you a picture here so that you clearly see what I'm referring to with Nodson-2-hit hypothesis. I want you to take a look at the patient on your left. This is the familial form. I want you to focus upon that. There is a mother and you see the father. You see the Greek signs. On your left is your father. On your right is the mama. The father here already has one hit. I want you to focus upon the colors of the chromosomes. It seems as though that all chromosomes that are orange are normal. The blue represents the mutation. That is your one inherited hit. How many more hits do you require to develop cancer? One more. Go down to the lineage, and you see the bolt of lightning down there at the bottom, and one hit was all that was necessary to bring about a second. Therefore, take a look at the retina in this patient. This is retinoblastoma, familial retinoblastoma. On the right will be your sporadic form. Set up the picture again. The father on your left, the mother on your right. You will notice that all chromosomes are orange, all normal. Go down the lineage. Progeny and you come to one lightning bolt. I just being silly here but this is your one hit. And then a sporadic second one comes along. Two hits now have taken place sporadically without any inheritance. This is the sporadic form of retinoblastoma, sporadic familial. I've given you two examples of familial thus far. They include the familial retinoblastoma. Here is familial, that's what I talked about P53. That's leishmaniasis. There is also others including familial melanoma. We will do special focusing on P53. P53 RAS was associated with 2050 with 25, 30, 50, 25, 30, 40% of cancer. P53 associated with 50% of all cancers. Now, keep in mind that you don't have to have just one mutation to bring up about cancer majority of the time. So maybe there is a mutation in RAS, maybe there is a mutation in P53, maybe there is a mutation elsewhere, ultimately giving rise to lung, colon, breast. What I'm saying is there will be many markers in which they will give you on your bars so that you know what kind of cancer you are going on to, unless it's something like familial, the special cases. I did one for you already. I did the one where the same patient had many familial cancers, and that was leishmaniasis. In response to cell DNA damage, what is it going to do? It will do everything in its power to make sure that the cell is properly repaired, or worst case scenario, it will remove it out of the cell cycle permanently. Welcome to execution. Programmed cell death, aka apoptosis. Would you please tell me what the name of the enzyme is that when results in apoptosis? Caspase 9. I want us to do special focus on APC. Let's begin. Where are you in the body? I want you to go into the intestine. That is where we are. So what are these? These are interstitial epithelial cells. These are enterocytes. If I tell you that these enterocytes are going to proliferate like crazy, what are you going to form? What are you going to see on lower endoscopy? What are you going to see, please? A polyp. Okay. Depending as to what kind of polyp you develop, you are increased in risk of cancer. What kind of colorectal cancer? With all that said, now that you understand where we are, now let's take a look at the molecular mechanisms. The first cell on your left is normal, no proliferation. By proliferation, what are you going to see again on scope? A polyp. And let's make this worst case scenario and we will see villus, or even worst case, why not familial adenomatous polypsis? Because that's where we are headed, familial adenomatous polyposis, FAP. Normal cell on the left APC, it controls beta-catenin. Take a look at the nucleus in the normal cell. TCF stands for transcription factor, and as long as APC is present, then beta-catenin is controlled or perhaps even dissolved. Therefore, there will not be excessive transcription. Next, I do want you to focus upon the swell. Be careful, students get this confused. I can tell you this, that this actually a derivative of a desmosome. Okay, but where are you? In a enterocyte. Watch this, you are going to love this. What's the name of the condition? We are going to knock out two birds with one stone. What is the name of the condition where you take a tongue depressor and you scrape the skin and the skin comes right off? It is a very vulgar disease, pretty much gave it away. Pemphigus vulgaris. It is a type 2 hypersensitivity reaction. IgG is attacking whom? The desmosome. So is this a desmosome? No. Why? What's a desmosome? That's in your keratinocyte, but attaches cell to cell. I'm telling you molecularly, ECFMG is a desmosome derivative. But what is it attaching? Not keratinocyte, but enterocytes, epithelial cells. Is that clear? I will come back to ECFMG. I don't want you to overlook it though. Big time important for you. In the meantime, though, let's go on to develop a familial adenomatous polyposis, FAM. So, here we have an APC mutation. You see that APC, the orange structure, is gone away. How beta-catenin has been released. It's working in the nucleus to then bring about transcription. Worst case scenario, what if APC is gone? It is mutated. Chromosome 5, so that APC has been mutated. Take a look at the last cell, and APC has been completely mutated. Nothing regulating beta-catenin. How much transcription activity are you going to have? Relentless, endless. Therefore, how many polyps are you forming? Hundreds upon thousands. I will show you a picture in gastroenterology where it is the carpet of polyps. When you have a carpet full of polyps, what is your risk of colorectal cancer? 100%. your order of hierarchy of learning APC beta-catenin, and you have another receptor on the very top here. The receptor that is responsible for communicating with APC and beta-catenin is called Wnt. I don't care how you do it, memorize it. If there is increased activity or resentless activity of Wnt, there is going to be increased activity of your nucleus and therefore bringing about polyposis. I told you not to overlook ecadherin. That is the second time I'm bringing this to your attention. In neoplasia, earlier when I was talking to you about with metastasis and such, I was talking to you about ecadherin. Your special focus in the word is adhere, okay? And what will adhere? Your enterocytes normally together. The two major cancer right now that I want you to focus upon in which ecadherin is negative. First, the primary gastric adenocarcinoma that is spreading to the left supraclavicular lymph node. Then it goes to the skin and it's called a laser chelate sign. And maybe hematogeneously will spread to the ovary, Klubenberg. This is the diffuse type of gastric adenocarcinoma. What is the number one prognostic indicator for breast cancer? Spread to the axillary lymph nodes. In lobular type of invasive breast cancer, ecadherin is usually negative, and you find that the breast cancer here loves to spread. You've lost your ability to adhere. Here is your full picture of APC. Make sure that you know it in great detail. Let's move on. Patients with mutation in APC is chromosome 5. At least no chromosome 5 develop FAP, familial adenomatosis polyposis, in which you would have resentless transcription activity and forming a carpet of polyps.